friends, I am Stravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in the series of data structures and algorithms, today we will see how to implement the remove method in a doubly linked list. So this is the doubly linked list that we have been playing with. Now let's say you wanted to remove the element which is present in the second position, that is 3. So now like just to try to understand, like in all my videos, first I have explained the procedure theoretically and then showing the code. So friends, I request you to understand the theoretical sense of it, because whatever in these days that we have gone through this pop or insert or append, all these things, right? These are the part of the main algorithms. So you may have to write a very huge algorithms, but this is kind of a very basic, so that on top of this basic you can build complex algorithms. Like before learning the sentences we learn alphabets, right? This is similar to that. Okay, so theoretically when we are talking, we have to, let's say in the second index we wanted to remove the second whatever way, the element that is present in the second index. Now what are the steps to do? Like let me put this out. Now if you see from the second we have these two parameters like pointers, and similarly from these three we have these two pointers to the next node. So the 3 is between 2 and 4 and it is having the pointers between these two nodes. So first what we have to do is, now we have the index in hand. What is the index? 2 is the index. That will be a user input. User wants to remove that element from the doubly linked list. Now let's take this whatever is there in the the index 2, whatever element is present in the index 2, that we consider that as temp. Once this is pointed to temp, now 2 will become temp dot previous, 4 will become temp dot next. That is clear, right? So before that, whatever to the temp, whatever is before it will become previous, next it will become next element. Now we have to strike out this pointer, these two pointers and these two pointers, so that, and we have to give the connection between 2 and 4. So this is how we can remove it. Now we have the 3, right? So for first we have to remove, for removing this, now this is the temp, 3 is the temp here. What we can do? Temp dot next means what? 4. 4's previous will become temp dot previous. So this is how whatever connection that we have from 3 to 4, that connection we are assigning that temp dot prev. Temp dot prev means to 2. So earlier temp dot next means 4, temp dot prev means 2, right? Now we wanted to have this temp dot next dot prev means it is particular let me take the red one. This particular pointer temp dot next dot previous, we are pointing to the directly to the temp dot previous, which is 2. Now let's take a text pad and write this down. Temp dot next dot previous means this is the pointer. Temp is 3, temp dot next is 4, temp dot next dot prev is the pointer. With that what we are doing? Temp dot previous. What is the temp dot prev? It is the number 2 in the node. Okay, the value node, the value means the data that is present in the node is 2. So we are directly pointing to there. Now this is the first step. Now what we have to do? We have to take, now this is the, from here to here we have to establish the connection, right? So that this entire thing will go off. So now what we have to do is temp dot prev to temp dot next. This connection we have to establish. So for that what we will say? Temp dot prev, which temp is 3, previous to temp dot prev dot next, means that pointer whatever from 2 we are going to point that to 4. So 4 is what? Temp dot next. Okay, now what we have done, if you see the red color lines here, right? If you see this red color line, this we have established and even this we have established. Now we have to break this thing, correct? So that this entire 3 is out of the league. So for that what we have to do, we have to assign none to those temp, so that it should not be pointing to 2 and 4 here. So for that what we will say, temp dot next equal to none and temp dot prev equal to none, so that this entire 3 is out of the league. Now this we will return in the code. Okay, then now what we will do, we will reduce the length and we will return the temp. Hope you understand. So this is how we will establish, like remove an element from the doubly linked list. Now this is the code that we are actually playing. Now let's take this code and test with this whatever we have seen for removing an element from the doubly linked list. Okay, now let's create definition remove self comma, we need the index on which index user wants to remove this. So here again we always talk about the corner cases, right? So here I'm just checking the get method. We already have the checks if the like index is less than or less is out of bounds, like out of the range of the doubly linked list length. But still let's write it. Okay, this is a duplicate code, I think, but still it is better if you only looking for remove method, right? So it will help those people. So we are saying that if index is less than 0 or index is greater than or equal to self dot length. Okay, then we say return none, because this is not a valid index. If index equal to 0 means they are passing the first index to be removed, right? So for that we have the pop method, we have already seen, right? Pop first, I think, pop first and pop. Okay, we don't have the code here, we can write it down. So after the pop, let's write so first we have to equal to 0, which means that if that list is empty. Sorry. Okay, now we will assign that like I have already explained this code in the pop first video, friends, so please go through that. I'll just complete the code. Self.length, we have to check whether only one element is there, then we will, because one element we have to remove, right? So self.tail equal to none, otherwise we will assign self.head equal to, we are assigning that head pointer to the next pointer, and self.head.pre equal to none, so that usually from the second element will become first element now, right? On that case we will have that left side pointer, so that one we are making it to none, and even the temp.next equal to none, so that from both side pointers are none, assigned to none now. Okay, now because this is a deletion operation, we have to reduce the length of the doubly linked list, and then we will return the temp. Okay, now let's go back to this remove function. So we have the pop first code now. We don't have to send anything, because pop first itself means that we are popping the first element. It doesn't need, we don't have to send the like user input for index. Okay, now if if it is the last element that we wanted to remove, that is another case, right? Self dot length minus 1. Okay, like fifth element if you say, but actually length is starting from 0 index, right? So that's why we have taken minus 1 here. If the length is 5, and if you wanted to delete the last index, which is that doubly linked list will start from 0. So 0 1 2 3 4, so that's why we are taking minus 1 here. So we know, right, which method to call. We have to call the pop method. Okay, pop method will eliminate the last record, last element from the doubly linked list. Now we have coded for all the corner cases. Now we have the code in hand that we have just written, right? So this is the code that we have written, and we have used temp here. So what is the temp here? Temp is nothing but we have to use the get method and the index. We have to get the data that is present in that index. So what is a get node? Okay, get node of, and here we have to pass the index. This index is coming from input parameter from this remove. So what it returns, it will, let's say we are looking for 3 in the diagram. If we give that index as 3, I'll take normal. Okay, yeah. So if we are passing the index as 2, it should pick up the 3 value 3. So that's why we are first calling it, so that we can have that index on hand. Now we have that. Now we will paste the code that we have just written. Okay, let me format it. So what we have done, first of all, we have pointed the cursors like pointers between 2 and 4, and then finally we have assigned none to either side of the temporary node. That is what we have done. And now, as I said, this is the code like element removal of the element, right? So we will say self dot length minus 1 equal to 1, so that length will be reduced. And finally we are returning the temp. Okay, now we don't have to insert anything, so I'll just comment this code as we copied from the previous lecture. We still have it. So after the print list, I'll say print dll dot remove, and I'll say 2. Okay, now let me run this code, remove of 2. Now if you see, it is printing all that whatever doubly linked list that we have, but it is actually giving the node. Here we have returning temp only, right? If we just put temp dot data and run, you can see 3 is printed here because we have passed the 2 index here. Let's say if I pass 4th index here, so instead of adding the data there, I will add it here, and when I run it, in the 4th position we have 4th index, we have 5 element, 5th element, like the node value is 5, 0 1 2 3 4. Okay, so we are able to remove this. So this is how remove functionality works in the doubly linked list. So friends, coming to the time complexity and space complexity. So people will usually say that in the doubly linked list, even if you see the code directly, right, you don't directly see the like any iterative actions are happening. So people will actually think that directly in the doubly linked list, the index, it will directly go to the index and it will just adjust the pointer. So they say that the time complexity of the remove method of doubly linked list is order of 1. But in my understanding, we are calling the get node method here, and in the get node, if you see, right, the pointer is starting from head and it is moving till the index is matching, and then it is returning the node to us. So what I feel is, because that iterative operation is happening here, the time complexity of remove operation in doubly linked list is order of n. Okay, and coming to the space complexity, as we are not actually doing anything with respect to the space here, and it's a constant time, so the space complexity is order of 1. Okay, hope this is useful to you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.